Okay, I'm gonna do 11 and 12 in one video because they're pretty short. And I just started my dishwasher too, so I hope you can't hear that. But use the data shown in the scatter plot to determine whether the data should be modeled by a linear function. And I actually have a ruler on here I can put. Hey, where'd the ruler go? There it is. The ruler. If I move my ruler around, it doesn't really fit all these points very well. And if I just, even if I drew a line like right here, and take the ruler away, you can see that I've got like, a bunch of points over here on this side, and then points over on this side. It's kind of scattered all over the place. So, that's a big no. It's not very linear. Doesn't look linear at all. So that's a no. I think common sense will tell you that. And then on 12, it says without graphing, determine whether the following data set is exactly linear. And keep in mind, they all have the word linear in them. This one says exactly. This one says approximately. And this one says non. And then they all say after that the word linear. Linear, linear, linear. So just don't give an answer. It's just, oh, it's linear. What kind is it? Okay, so I am going to start by looking at the x's. When you go from 1 to 2, and from 2 to 3, and from 3 to 4, and 4 to 5, that is the change in x is an increase of 1 every single time. Remember the little triangle is actually the Greek letter delta. It means the change instead of me writing the change in x. But every x is separated by 1 unit, and they're all increasing by 1. And then if I go and I look at my y's, when I go from 9 to an 11, that's an increase of 2. From an 11 to 12 is an increase of 1. From 12 to 15 is an increase of 3. From 15 to 17 is an increase of 2. It's going up. It's constantly increasing, but it's not always the exact same amount, so it can't be exact. But it's close. Up 2, up 1, up 3, up 2. It's close, so I'm going to go with approximately. In order for it to be nonlinear, it would have to be something like plus 2, plus 8, then minus 6, then maybe plus 1, then maybe minus 7, then maybe plus 12. It'd be all over the place, which means your points would look like that. They'd be all over the place, okay? This is actually something that is nonlinear. So on this one, however, if I were to plot these points, on a graph, you would see them like 1, 9, 2, 11, 3, 12, 4, 15, 5. So I'm not doing a very good job, but I don't have any numbers here. But it's not perfect, but it's going uphill and it's pretty close. So the answer to this problem would be approximately linear. So don't just say linear. All 3 answers have the word linear in them, so I don't know. I'll take off for that. All right, so 11 and 12. There you go.